This video, we are going to learn how to find curvature of a smooth curve. So the smooth curve is given to be r of t equal to f of t I plus g of t j. R of t gives the position vector of any point along the curve at time t. F and g are twice differentiable functions. In this case, x is equal to f of t and y is equal to g of t. We are going to show that curvature of this curve is given by this formula. Now let's start with the formula of curvature of any curve. If the velocity of a curve is not equal to 0, then the curvature is given by magnitude of the cross product of velocity and acceleration of the curve divided by cube of the magnitude of velocity vector. So let's start with the position vector of any point along the curve. Since r is fi plus gj and f is given to be x and g is given to be y, so the position vector of any point on the curve is r equal to xi plus yj. Now what is the velocity? Velocity is nothing but the derivative of position vector with respect to time, and in this case it turns out to be x dot I plus y dot j. So what is the dot here? It denotes the derivative of the x with respect to time, and y dot denotes derivative of y with respect to t. Now let's move on to finding acceleration. Acceleration is the derivative of velocity vector with respect to time. So we take derivative of these with respect to time, and x double dot denotes the second derivative of x with respect to t. Y double dot denotes second derivative of y with respect to t. Now let's find the cross product of v and a. For that, we write it in this determinant form ijk. The first row after that is component of the velocity vectors. The next row is component of the acceleration vectors. Now we find the determinant of this matrix and simplify to get the cross product of v and a. So now we have the cross product. The magnitude of the cross product is nothing but mode of the coefficient of k. Alright, so now we need to find the mode of velocity vector. Since velocity vector is given by this, the magnitude is x dot square plus y dot square whole raised to power 1 by 2. Okay, so we simply substitute these two values in the formula for the curvature, which is this, and we get our answer.